there are some waves that are transverse, such as the water waves and waves set up in what? In strings. In what?
Strings.
In strings. For example, this is a pole, and you have a string connected to the pole, and then you have a disturbance like this. This is your hand. This is your hand, you know? Do you understand? So when we say something is what? Transverse. It means the vibration is perpendicular to what? To the transmission or propagation of the wave. Are you with me now? So if they ask that, which of the following is a longitudinal wave? A, wave set up in a spring. B, wave set up in a string. C, gamma ray. And D, visible light. What is the answer? Wave set up in what? In spring. Thank you. That one is longitudinal. So when we say mechanical and electromagnetic now, there are some in mechanical that are what? That are transverse. But all electromagnetic waves are what? Transverse. They are what? They are what? They are what? Please don't forget that. We have what is called the general equation of a wave. What did I call it? The general equation of a wave. It is given V equals what? F times lambda. It is as well equal to what? Where V is what? The velocity of your wave. F stands for what? The frequency of your wave. And this is your what? Your wavelength. Why this is your what? Your period. Your what? Period. The relationship that frequency has with period is simple. Why? Because we define frequency as the number of cycles you make in 1 second. So if I'm making this cycle, the interval you have might be up to 2 seconds, right? Do you know that I can have a cycle like this? So which means I'm having like 2 strokes more than one. Within what? 1 second. So I'm having what? 2 strokes. Do you get what we mean when we say the number of cycles made in what? 1 second. So if they now tell you that the frequency of a particle is 50 Hz, what does that mean? It's frequency. The strength of your network, the strength of your phone network is around 50,000 Hz. What does it mean? It means your network is making a cycle of what?
50,000 in 1 second.
1 second. What is the frequency of the Nigeria electric grid? Or may I say the electricity that we are supplied? What is the frequency? So you don't know. Is what? 50 Hz. So it means that once they on it from their station, it will make a cycle of what? Up to 50. Before what? 1 second. So that's why you can't see it as it's coming. Maybe from to what? This is the general wave equation. Now what is period? We say period is the time it takes to complete what? Can you see the relationship? The number of cycles you make in 1 second and what? The time it will take you to make 1 cycle. Hello? So which means if from here to here it takes you It takes you 10 seconds. Do you know that there are some objects that what? Hello, before 1 second is eh? Do you understand when we say period now? Very. Now, when it now comes to the transverse wave, we have another equation. Okay. I'm telling you, there are chances that you may not see somebody that will explain like this to you. Now look at this, and then look at this. Are they the same?
No.
Why? Both are sinusoidal. But one starts from where? The origin. The other does not start from. Anytime you see any graph like this, you should know that it's a cosine graph. What do I call it? Cosine graph. Anytime you see a graph like this, then you should know that it's a what? A sine graph. So if you now be part of those that are asking that, why did they again? Lift, which is related to the horizontal that you call theta, will vary. Will what? Will vary. Are you with me? Good. Now, this is called the y-axis, which is the peak. Let me give you a clean diagram of this. This is your y. We want to relate y to what? A. Class, we have some terms we use in describing waves. We have A, which is called amplitude. We have T, which is called frequency. We have F. Thank you. Somebody says small t. Thank you. We have F, which is called what? Frequency. We have V, velocity. We have this, which is called what? Angular velocity. We have phase angle, and so on. Now, somebody said small t. What is the difference between big T and what? Small t. Small t. Period is not time. Small t is time. From here to where it's going is small t. But big T is concerned with what? The time it takes to make a cycle. And what's the cycle? From here back to hello. This is the amplitude, the maximum what? Now look at this. This one is always regarded as your y, your biggest what? Y. I'm talking of in terms of length now. So if this is your theta, and this is your A, which is what? Look at it. This theta, this is A, and this is your y. Are you with me? What trigonometric ratios connect opposite to hypotenuse? Sine. Very good. So because of that, we are going to have sine theta equals what? Opposite. Oh, sorry. It's going to be this. This is what's amplitude? What's amplitude? Maximum what? Maximum what? Displacement. Is the maximum displacement. So now you're going to have this as your y instead, please. And this is going to be your what? Your A. Yes. Although you have it as this and this because it's a sine. But because amplitude is the maximum displacement, this could be your y. This could be your what? Your y. Are you with me? But this is what the maximum displacement. So maximum we take for hypotenuse. So by the time you cross multiply, what are you going to have? You have y equals what? Equals a sine theta. But in some cases, they can represent with what? Small a. Are you with me? That could be why? Because we can have more than one particle propagating. Are you with me? You can have what? One or more particles propagating. So because of that, you just find what? Their difference in the angle with which they start lifting. Are you with me? Now, don't forget that this situation is simple harmonic. Is it not simple harmonic? Simple harmonic is under simple harmonic motion. That's why they have so many relationships together. Now, under which we were told that in simple harmonic motion, how do we define angular velocity? That is the speed in terms of angle. That is what? Displacement over what? Over time. How did we get this is equal to what? 2 pi f. Another time I will explain. Or if you want me to explain, anytime you want me to explain, I will explain. Alright? What are you going to have? Can you see? So in the place of this, do you know that we can say that our y can be what? A sine what? Are you with me? When you make this relationship, omega is equal to what? Theta over what? So if you make this the subject, what are you going to have? Then plus or minus pi. Are you with me? Why do we have an introduction of 2 pi f? I want to transform this to a what? A circle. This to what? A circle. This is your particle. Moving from here, then it now moves to here. Or it moves beyond. The time it takes it to move from here to here is what? But if it's meant to move from here, then back to here, you don't call it t again. What are you going to call it? So because of that, your omega is going to be what? Theta over what? Big T. Are you with me? Very good. Now, what's the relationship that big T is having with frequency? We say it is what? 1 over f, right? And by the time you express this, what are you going to have? You have omega equals what? Theta and what? F. Right? Now, since your angle has been made to complete what? A cycle. What is that? What is your theta? Your theta is made to complete a cycle. What is that? Thank you. Your theta is what? 360 degrees. But we describe this in terms of radian. And we said that 1 pi is equal to what? 1/8. So 2 pi will be what? So because of that, instead of having theta as 360, what are we going to have it? 2 pi. So because of that, we say what? Omega is what? 2 pi. Are you with me now? With what? Here. You guys are outside. Okay, let me just stop. While I was coming, I wanted to minus what? 2 pi x over what? Lambda. I'm supposed to explain this to you, but because of your continent, just f over what? Lambda. So it's basically, the reason why you have it plus or minus is because in some questions it can come like this one can come front and this one can what? Go back. Just change the direction you are having. That is, you can have 2 pi x over lambda plus or minus what? 2 pi m. Sometimes you can have it as y equals a sine vt minus what? Minus x. V is your velocity, t is your time, and x is your distance horizontally. Are you with me now? Very good. Now, the reason why I have to explain like this to you is because of the question that I gave that looks like this. I guess that was the last question, right? Very good. So, we shall see which one are we going to.
Jet is embedded in a block of ice.
an object is embedded in a what?
Block of ice 10 centimeters below the plane surface.
Below the plane surface. Below it 10 centimeters.
If the refractive index of the
You
ice
now have
is
refractive index
1.50,
1.50.
the
Yes.
apparent depth of the object below the surface
The
is
apparent length of the object.
not length to depth.
I can't tell you what?
Depth.
The apparent depth of the object below.
Below the surface.
Please call the question again.
An object is embedded in a block of ice.
Very
10
good. An object is
centimeter
embedded in block of ice
10 centimeters below the plane surface.
below 10 centimeters below the plane surface. That is the real depth. Yes?
If the refractive index of the ice is 1.50,
Listen. The real depth given is when they stated it that the object is seen below the plane of the ice. That is the real depth, which is 10 centimeters. Yes? They gave you refractive index of 1.57 and they asked you for what? Apparent depth. What is refractive index in terms of real depth and apparent depth? We say refractive index is what? Real depth over what? Apparent depth. But what's our index? What is real depth?
10,
Over what?
80.
Then what are we going to do to get our apparent depth? And what's the answer? 6.777. And that's what? Is it? Please call the options. A.
8.
Have you ever seen this before? They say lateral displacement is equal to what?
Fine.
No, not time. Oh. Thickness of the medium, which is also known as what? Real depth. The thickness of the medium is also known as what? Real depth. Into bracket 1 minus what? N is what? Your refractive index. That's another formula. Please, I'm begging.
2 meters.
Is what?
42 meters.
Okay, the wavelength is 42 meters, yes.
What is the period?
What is the period? What equation are you going to use? The general equation. All you want, you use this. You first get frequency, and then you now say frequency equals what? 1 over 2. You get the same thing as when you use this, alright? So just impute it. What are you going to have? What's your V? 420, and this is 42, then T. So when you cross multiply, you have T equals 4 over 420.
0.1.
So which is what? 0.1 what? Second.